Hi, this is our Capstone project presentation, and we are Real-Time 7 Incorporated VIPER AI camera firmware. My name is Jacob Jansen, and on my team, we have Saeed Almeri and Zach Sanchez. So first, our project description is an Internet of Things camera that has AI-based object detection and recognition that all happens in real time. So that basically just means as the frames come in from the video camera, the video processing occurs. And we're using this is an embedded C++ software project that works with ARM64 processors, NPU, GPU, ISP, as well as some other hardware acceleration. And we're working with and manipulating JPEG images using GPU and CUDA for real-time frame manipulation. So we are actually processing the results through deep learning CNN models to gather intelligence about the contents of the video, and then we're storing them in accompanying metadata files. And in these files is where we're doing all of our analysis and guessing, which we'll expand on later. And then after that, we release any clean resources after the processing is complete. Next, our development environment is primarily VS Code, which uses a G++ cross compiler. Our learning model is an RL controller, which stands for reinforcement learning, and is used to guess whether a particular frame has motion or no motion. So we use this controller by gathering some test cases, which train the controller based on the events happening and whether is no motion and no motion being known. And then we use that against another test case in which the controller actually guesses whether each frame has motion or no motion. And then we've used different methods to improve the overall accuracy of the controller, such as having some RGB cutoff values, which eliminates subtle motion and stuff like that. And for our project overview, the overall purpose of this project is to be able to do object and motion detection on actual camera footage using our code that we have created and put in place. The overall goal was to predict whether motion is present in an image with somewhat accuracy. And currently the guessing rate is over 70%. So I think we're around sitting 75 to 85% right now. And hopefully that can just only be improved upon. Some motivation for the project is to notify users about what objects are present in the camera view and if there's any motion. So this is kind of a security type thing. The users can put the cameras wherever they want and the object detection and motion will take place. Some requirements for the project were first to set up the environment. Obviously, this is on all the developers need this on their local computers. Next step was then to develop some test case videos that accurately covered different types of motion that can occur in front of a CCTV camera, which is basically just a surveillance camera. And then we wrote some code to guess whether a frame contains motion or no motion at the highest accuracy. So throughout our project, we were always trying to improve the accuracy of our guessing of the controller. And continuing on some more requirements, the customer discovery process was pretty straightforward. The sponsor identified there's a need for better object and motion detection, and the primary users will be homeowners looking for some more security, using our object detection and motion recognition wherever they need, whether it be in the front of their house, the back of their house, basically providing them with the tools that they need. And the requirements did not have to change at all throughout the project, really, because as we progressed, different functionalities were implemented only in steps and tested very thoroughly against our test cases that we gathered. So the requirements did actually not have to change.
For our technology decision in our project, we went with the C++ programming language as our foundation. We use C++ because it's fast and efficient, allowing us to conduct multiple complex calculations to be performed in sub-seconds time. Additionally, it's able to operate on embedded systems, such as our project live feed camera. Another technology we utilize is OpenCV C++ library. We rely on OpenCV for real-time computer vision, such that we can get our camera feed in real time. Another reason we use OpenCV is that it allows us to process and manipulate images from our camera, and it includes built-in functionalities. Furthermore, we use TensorFlow Lite as a small machine learning library. It allows us to perform image recognition on the camera feed to get the objects in the scene. It is also a mobile library such that it can operate on low-performance devices and embedded systems internally without the need for external devices. So for our design decisions, we went with using command line arguments as a way to run our programs. It allows us to run pre-written tests sequentially and autonomously, and remove user errors from the equation as it guarantees the test's consistency. Command line arguments allows us to speed up and run different processes without the need of rebuilding the program or changing things manually, as the command line parser handles different inputs. Furthermore, our second design choice is to utilize OpenCV for image processing. The reason being is that it has built-in functionalities for image processing, such as scaling, masking, generating absolute difference, and color filtering. Another reason would be is that it preserves the image data into matrices such that we are able to manipulate and perform complex calculation on data efficiently, without the need of writing and rereading images. At the end of this semester, we were able to develop two results. The first one is our numerical analysis code. It reads in frames as an OpenCV matrix, calculates the absolute difference of the frame against the average mean and standard deviation, adds frame to the average, composing a running average, generate the absolute difference of each frame of the running average, as you can see here. At the end, it reports back each frame absolute difference, mean, and standard deviation to a CSV file for further analysis. Here is a demo for our numerical analysis code. We input the data path and the starting and ending frame index. Here we could see the running average absolute different images. Here is the output CSV file containing each frame's mean and standard deviation for analysis. The second result is our reinforcement learning model to detect motion and non-motion in a frame. It reads in the average difference images as an OpenCV matrix, calculates their mean and standard deviation, generates a reinforcement learning matrix, trains the reinforcement learning model on different pre-labeled datasets, runs the reinforcement learning model on untrained datasets, and returns the results to a CSV file, like the one shown here, to measure the model guessing accuracy. Here is the demo for our reinforcement learning model. We pass in the data path to populate the RL matrix. Here we can view how the RL is stored and populated. After we trained our data, we will run it against untrained data to generate guesses. Here we can view the outputted guesses and measure the model accuracy.
Now, one value that we created would be an economical one, as we were able to lower the cost of business that utilizes the camera surveillance software, as they will no longer need an extra employee or security person to monitor the footage, as all movement in that area would be detected by the software. Another value that we created would be the social aspect, and they were able to create a peace of mind for those that utilize the motion detection capabilities, as they know and able to view for themselves that all objects within an area is detected and any motion be recognized, giving them a sense of safety. Now, for the lessons that we've learned throughout the process, one main thing would be the importance of clear and consistent communication between the development team and the product owner. As without this, there will be many instances of miscommunication, having to go back and forth and ultimately decreasing the amount of actual time that we have to work on the product. Another being to responsibly delegate tasks between the development team and playing to their strengths, and making sure that they're able to meet their deadlines. We've of course had extended deadlines in case there's any possible complication during the development process, because without that, then we would ultimately fall behind at the sprint. So we gave ourselves some leeway time in case we fall into those complications, or helping others with their tasks and duties. For future development plans, we've also tried to increase the motion detection accuracy using the RL controller. As you can see in this figure, is the motion detection between a normal frame and RL controller. We're hoping to increase that accuracy of the whole frame. We also increase production line value initializer program in order to keep up with demand of those that are able to use this system, and to have a camera software updater that's able to in real time update the software within the camera to make it fast and efficient. In conclusion, we hope to increase accuracy and functionality of the product as we discuss with the product owner, and to any other change in plans or in ways to improve the product. We utilize the Tiger board to keep track of current and future tasks for our sprint, allowing us to have clear the length and allocation of tasks between those in development, and able for the product owner to know who is working in which aspects. Thank you very much for your time.